Coming back with worksheet number 5, part 2 video. We're looking at number 3 in interpreting chemical equations. So the first thing we want to do is let's balance out our equation, right? So we want to separate, of course, our reactants and products. I've got one nitrate here, NO3, and one nitrate there. I have one silver and one silver. I have one chlorine and one chlorine. And I have one sodium and one sodium. So nicely enough, these are balanced out, 1, 1, 1. So that was nice. Okay, so now let's start working and interpreting what these mean. All right, so when I look at my first thing here, I know that this is going to be AQ is aqueous. So I'm going to say that this is aqueous. And now I need to name this. If I look on my ion sheet, Ag is silver and NO3 is nitrate. So I'm going to call this silver nitrate. So aqueous silver nitrate. And then I'm going to look next, and there is the plus sign. So the plus sign, remember, means reacts with. So aqueous silver nitrate reacts with. And now let's look at our next compound. It's NaCl with an AQ. Remember, the AQ stands for aqueous. So aqueous silver nitrate reacts with aqueous something, NaCl. This is a metal and a nonmetal. It's ionic, so I'm going to look on my ion sheet. Na is sodium, Cl is chloride. So I'm going to call aqueous sodium chloride. And then from there, I've got my arrow. My arrow means after these two things react, you're going to form or to yield. So aqueous silver nitrate reacts with aqueous silver chloride to yield. Yield means creates. To create. And let's see what we have. Let's do blue. Next is AgCl with an S. Remember, the little s stands for solid. So it's going to yield solid AgCl. Ag is silver, so it's a metal. So ionic compounds means that you look at the ion sheet. Ag is silver, Cl is chlorine for chloride. So it's going to be solid silver chloride. Right. And next is the plus sign. Remember, the plus sign on the product side means simply and. So this reaction is going to create solid silver chloride and one other thing. What is that other thing going to be? NaNO3 with an AQ. AQ stands for aqueous. So it's going to be aqueous. And then NaNO3. Well, Na is sodium. Sodium's a metal. So a metal means it's going to be an ionic compound. So I'm going to look on the ion sheet. Ion sheet says Na is sodium. And when I look at NO3 on the ion sheet, it's called nitrate. So sodium nitrate. All right, and there you have it. We've interpreted by reminding ourselves, hey, how do I name these compounds? What do these little letters mean in the parentheses? We put it all together, and now we've interpreted our chemical equation. Nice work. Working with question number 4, first thing we do is let's make sure we can balance this equation. So if I take a look, my carbonate, CO3 and CO3, there's one of each, so that's equal. But it looks like my chlorine isn't balanced on both sides, so I think I'm going to need to drop a 2 in there. By dropping a 2 on the sodium, I have 2 sodiums over here, so that's balanced. So it looks like magnesiums are balanced too. I think everything is balanced out now. We just needed the 2 on the sodium and the chlorine. So that's a 1, 1, 1, 2 to balance it out. All right, so that looks good. I'm just cleaning this up a little bit so that we can see it. But let's move on to interpreting what this equation means. Let's take a look at our very first part of this equation. We'll look, and it's AQ. And we know AQ stands for aqueous. A-Q-U-E-O-U-S. Sometimes aqueous is a little tough to spell, but that's aqueous. Now we're looking at this. Magnesium and chlorine are coming together. If you look, magnesium is a metal. So when a metal and non-metal come together, that's ionic, which means we need to look at our ion sheet for the naming. So the magnesium ion is just called magnesium. So that's what we'll call it, magnesium. And then chlorine becomes the chloride ion. So we just call it chloride. So this is going to be called aqueous magnesium chloride. And then I accidentally went over this a little bit, but now, there we go, it's uncovered. We've got the plus sign. The plus sign, we know, means reacts with, right? So aqueous magnesium chloride reacts with, and the question is what? What is it going to react with? So let's look at the next thing. Reacts with this object, Na2CO3AQ. So first of all, if it's AQ, we know it's aqueous again, so we'll say that. Remember, it is important to talk about its physical state because it's like a recipe, right? If you're gonna add butter to a recipe, sometimes it's melted, sometimes the butter is softened. If you're gonna make a biscuit dough, you're gonna have the butter super cold or even frozen. So the physical state matters in a recipe. It's the same thing for a chemical reaction. So saying it's aqueous and that it's dissolved in water is important. So if I look here, Na2CO3, sodium is a metal. So when you have a metal, we know it's ionic, so we just use the ion name. So it's gonna be sodium. And then if you look at CO3 on your ion sheet, take a look, that's a polyatomic ion. CO3 is called carbonate. So this is gonna be called aqueous sodium carbonate. Now after that, those two reacted together and we have the arrow there. Let me erase that. I've been drawing so much here that you can't even see it. It's covered up, but there it is. There's my arrow. Remember, arrow means like to yield or to produce. So aqueous magnesium chloride reacts with aqueous sodium carbonate to yield or to create or to produce something else. What is it? Well, let's take a look. I'll do the color black here to circle. And we've got something that's the letter S. So the S is solid, so it's going to yield something solid, and it's MgCO3. If you notice, we've already used Mg magnesium, and it just switched around. So since magnesium is a metal, we know it's ionic, so we're gonna use our ion naming sheet. So let's call that magnesium, and then CO3 we already looked up, that's called carbonate. So really the ions, if you're noticing, are just switching places. Instead of the sodium with carbonate, now magnesium's with carbonate. All right, so that made magnesium carbonate. Now if you take a look, there's another plus sign here. Sometimes people get confused and they say, whoa, I thought a plus sign is reacts with. Only on the reactant side is it reacts with. On the product side, it just means and, meaning like what things are actually formed. So solid magnesium carbonate and something else are formed. So let's do that. It's going to be NaClAQ. AQ stands for aqueous, we know. We've used it for quite a few of them in here. And then Na, sodium, is a metal, so this is going to be ionic. And ionic, we just use the ion names, meaning you're not going to use prefixes like mono, di, and tri. And then Cl, chlorine, is just called chloride because it's not monochloride, because it's an ionic compound. So there you have it. Aqueous magnesium chloride reacts with aqueous sodium carbonate to yield solid magnesium carbonate and aqueous sodium chloride. Woo! This is great practice though, because not only is it forcing you to interpret what the balanced equation means, but it's also forcing you to think back to how do I name compounds? So great job. There's another example for you. Let's finish up our examples with number 5 and try this one out. So if we take a look, let's balance this. It looks like I have 2 sodiums and 1 sodium. So if I put a 2 there, that's not only going to give me 2 sodiums, but 2 bromines as well. Well, now if I look at my bromines, I have 2 bromines over here and 2 bromines over there. So that's balanced. So that's good. Calcium, I have 1 calcium, 1 calcium. Perfect. And carbonate, I have 1 carbonate, 1 carbonate. So it looks like I'm balanced here with a 1, 1, 1, 2. let's start with our first compound. So our first compound is CaBr. Notice it's AQ. AQ stands for aqueous, meaning that it's dissolved in water. If I look at Ca is calcium, and that's a metal. So since it's a metal, we use for ionic compounds only the metal and nonmetal names. Look on your ion naming sheet to help you. Br is bromine, but we know when it's in an ionic compound, that turns to bromide. So first we're going to start with aqueous calcium bromide. Now if I uncover, take a look, there's a plus sign there. Remember the plus sign on the reactant sign means reacts with. So aqueous calcium bromide reacts with something. Let's take a look at what that something is. Na2CO3, and it's got an AQ for aqueous. So it's going to react with something aqueous. It's going to react with aqueous, and then there's Na2CO3. Na is the element sodium. Sodium is a metal, so this is going to be ionic, so we're not going to use prefixes. So it's going to be aqueous sodium CO3. If I look at CO3 on my ion sheet, that's a polyatomic ion called carbonate. Sodium carbonate. All right, so aqueous calcium bromide reacts with aqueous sodium carbonate. So if I erase a little bit here, what's left is that arrow in between. Remember that arrow means to yield, meaning to create or to produce. So after the aqueous sodium carbonate, it's going to yield something else. So let's take a look at that. Up next is CaCO3S. Remember the S stands for solid. And Ca is calcium. Calcium is a metal on the periodic table. So it means that you would use calcium for an ionic compound. So look on the ion sheet. We just call it the calcium ion. So the calcium ion combines with CO3. We already named CO3. We know that's carbonate. So solid calcium carbonate is created. That's like sidewalk chalk. And then if we erase really quick, we can see there's a plus sign underneath there. That plus sign, remember, doesn't mean reacts with on the product side. It just means and for what two things were created. And then last but not least, you've got NABR-AQ. So AQ stands for aqueous again, which means that it is dissolved in water. And then we just have to name this compound. NABR, it starts with Na. Na is sodium. Sodium is a metal, so if it's a metal, this must be an ionic compound. And ionic compounds do not use prefixes. We just use our ion naming sheet. So we would call this sodium, and then bromine's name is bromide in ionic compounds. So it's going to be aqueous sodium bromide. So in the end, this whole super cool, compact, full of information equation, let me clean it up here really quick for you, really just means aqueous calcium bromide reacts with aqueous sodium carbonate to yield or to create or to produce solid calcium carbonate in aqueous sodium bromide. Wow, we interpreted it. We also got some great practice with naming ionics. This is fantastic. Now, if you're struggling with the naming, that means you need to go back and restudy and re-practice some of your ionic compound naming. If you can name it, then this is pretty straightforward. But nice job, science fam. Hopefully this makes a little bit more sense and gives you a little idea of, hey, there's a lot of information packed in these chemical equations. Take care, be well.